Everyone, this is Abdul from DeepVu, and I'm very excited to demo our AI for resilient demand planning for Dynamics 365 and Azure Marketplace. As a high-level overview, resilient demand planning is essentially AI decisioning agents that simulate shock scenarios, such as a drop in consumer spending, and recommend a decision on the demand plan that boosts your accuracy. As you know, with forecasting models, once there's a major change in an external signal, then the model's accuracy could easily drop by 15 to 25 points, since the patterns are quite different from the historical training data. We've seen that happen in the pandemic and the major shocks of the past 3.5 years. So for the Vudecide Demand Planner app, which is our SaaS offering, you can see that we have 3 buttons here: initial setup, decisioning, as well as planning. So in the initial screen, you'll see this questionnaire button where you will be asked a few basic questions about your product and the industry vertical that you're in, as well as the supply chain shocks that you have in mind. In this beta release, we support one type of shock, which is consumer spend, the government's personal consumption expenditures dropping by 20 or 10%. I won't go through that now in the interest of time. So in initial setup, you'll need 2 input files: the historical demand dataset, as well as your current baseline forecast. This could be from the Dynamics forecasting app or your own internal forecast. Both will need to be CSV files with the same cadence, ideally of weekly cadence. We can also work with monthly cadence, but we don't recommend it. So I'll upload these 2 files. For our demo, it's a government data set, which is the gasoline sales in the United States. So there's the historical gasoline data. Now I'll upload the forecast baseline file. So I've uploaded these 2 files. In your case, these buttons won't come available immediately. You'll have to wait for our team to review and validate the data for consistency. Then we'll notify you via email once your AI agent has been trained. So in the decisioning flow, we'll start by choosing the scenario you're interested in. In this case, it will be a shock scenario. And we'll select a drop in consumer spending by 20%. So I'll need to specify a decisioning horizon I'm interested in. So I have actuals for this data set until February 18th, and I'll specify a horizon that starts from March 15th through to the end of May. And now I'll upload the actual demand file. So here we're interested in 2 columns, which is the DeepVu demand as well as forecasted demand. This would be the baseline forecast, and this would be the result from the decisioning agent. We can see that the 2 values will differ. But now we're interested in how well the decisioning agent is performing. So I'll go back to the planning section, in which I'll select our same parameters that we've chosen in decisioning. So I'll start the planning start date from December of last year. So we look at two rows as an example. And here we're interested in three columns, which would be real demand, forecasted demand, as well as DeepVu demand. We can see that the baseline forecast overshot the real demand quite a bit, whereas the DeepVu decisioning achieved a much closer value. And in this week, in February, you can see that the baseline forecast actually undershot the real-time demand. And again, DeepVu demand is performing much more accurately. So if we look at the aggregate statistics per week in this view, we can see that the error for the baseline forecasting is much higher than DeepVu's error. And again, we can see that the decisioning is performing much more consistently in these shock scenarios. Thank you for watching, and we hope you try the agent and let us know your comments and feedback. Thanks.